Good day, students. Welcome to mathgoodsurf.com. And this clip, we're going to be going over how to solve systems of linear inequalities by graphing. All right, so the instructions for the problems we're going to be solving are as follows. We're to solve the system of linear inequalities graphically. Okay, so for problem number one, what if we have the system y is less than negative 3 over 2 minus 1, x minus 1, and y is less than or equal to 1/2 x plus 3. All right, so in this case, we have two linear inequalities that we're going to be graphing. Let's call this one 1 and call the second one 2. Now let's go ahead and graph the first one. So we have y is less than negative 3 over 2x minus 1. So this is in slope-intercept form. Basically, it tells us what the slope and the y-intercept are. So we recall y equals mx plus b. You can see that b is negative 1 and m is the coefficient of x, which is negative 3 over 2. So m, our slope, which is rise over run, is negative 3 over 2. Which means that starting from our y-intercept, we're going to drop 3 units and run 2 units. Our y-intercept, which is b, is negative 1. So that's where we're going to start from when we're graphing our y-intercept, okay? All right, now let's go ahead and set up our system, our coordinate system. So those are our y-coordinate, that goes our x-coordinate. Let's graph line number 1. Okay, so for line 1, we have the y-intercept is negative 1, so we have a point here. And then we're going to rise negative 3, 1, 2, 3, and run 2, 1, 2. All right, so what is our line going to look like? So we have some effects that we're going to be applying to our lines because we have an inequality situation here. Okay, so we have this less than. So what does less than mean? Less than alone means that we're going to shade down below the line, and we're going to, the line is going to be broken. Okay, it's going to be a dotted line. A dotted line where you shade down. Okay, so that's what we're going to do here. So let's go ahead and graph that. Okay, so there goes the line. So we're going to be shading downwards. So I'm just going to put in arrows to indicate the direction of our solution region. So it's going to be less than. All the collection of points to the left of this line is part of the solution set, okay? So we're going to ignore all this. That's not part of the solution. This area right here is part of your solution, okay? All right, so let's keep that in mind. Now we're going to go ahead and graph the second line, the second linear inequality. So the second one, we have another equation in slope-intercept form, which is very straightforward to graph. Y is less than or equal to 1/2 x plus 3. Now, the slope, m, is 1 over 2, the coefficient of x. So we're going to rise 1 and run 2. Where do you start from? You start from a y-intercept, which is b, and that's the constant right there. 3, that's where you start on your y-axis. Now for your effects, how does that less than or equal to affect the line that you're graphing? Since it's less than, we're going to be shading down just like the previous one. But since we have that inclusion line there, it's going to be a solid line. All right, so let's go ahead and graph the y-intercept 1, 2, 3. And then we're going to rise 1 and run 1, 2. Okay, so we're going to draw a solid line going through that point. That will be our solution region. So let's see something like that. All right, now the direction of our shade is downwards, just like before. So we have to have an arrow pointing down and an arrow pointing down. Okay, so where is our solution region? We have 4 regions. Let's call this 1, this entire space here. This is 2, 3, 4. Now, which of those 4 regions can we call our solution region? Now, the solution region is a region that arrows from both lines are pointing to. If an arrow is not pointing into, if one or more arrows are not pointing to any region, then that is not part of our solution region, okay? So let's go ahead and see if we can identify the solution region based on the direction of our arrows. Now, this one, put the points back in there. Region 1 is a fail because neither of the arrows are pointing there, so this is not a solution. Region 2, this line, the graph from line 2 is pointing outside this region, so this is not an answer. Region 4, only one arrow is pointing there, so that's not an answer. Take a look at region 3. Both arrows are pointing in this direction, hence, this is our solution region right there, okay? So just let the arrows be your guide and you will be able to graph the solution region without making a mess on your paper, all right? So just shade this region right here. And this right here, what we can do is let's just name it. Let's name it region S. Okay, so region S is the solution to the system of linear inequalities, to the system of linear inequality. Okay, so that's basically how you solve linear inequalities by graphing. All right, let's take a look at another example, problem number 2. Now, what if we have x plus y is less than or equal to -2, and in the second one, -5x minus y is greater than, actually less than 2, less than -2. Okay? All right, so the difference between this one and the other one is that this one is presented in standard form, and we need to do some work to graph it. Okay, so there are 2 ways you can do this. You can use intercepts to generate the points, or you can use slope-intercept form. Now, for inequalities, it is very important to use the slope-intercept form because that will give you the correct orientation of your inequality symbol. All right, so keep that in mind. So you have x plus y is less than -2. So I need to get y isolated, subtract x from both sides, and that yields y is less than or equal to -x minus 2. In this case, the slope is -1/1, coefficient of m, and your y-intercept, where you start on the y-axis, is -2. All right, so let's look at the effects for this line. We have less than or equal to. So what does that mean? It means we're going to have a solid line, and since it's less, solid line, and since it's less than, we're going to be shading downwards. Okay, solid line, shade down. All right, let's go ahead and graph this line. So we're going to start with our y-intercept, okay? Y-intercept for this line is -2. So we're going to rise -1, 1, and then run 1 down, okay? So those are the points that define our line. It's a solid line that we're going to be shading downwards, all right? So let's go ahead and draw that line. All right, so what's the direction of our shade? Since we have less than, every point below this line, including the line, satisfies the first inequality. Okay? All right, but we're looking for the intersection of the points that satisfy both. That's our solution region. So we need to now direct our attention to inequality number 2, which is also presented in standard form. Negative 5x minus y is less than negative 2. So to get y isolated here, we start by adding 5x to both sides. Okay, and then we have negative y is less than 5x minus 2. To get y isolated, we'll divide everything by negative 1. And we end up with y. Now, when you divide by negative, what happens to the orientation of your inequality? It always flips, okay? So don't forget that. It becomes greater than or equal to negative 5x plus 2. All right, so our slope here is negative 5 over 1. We're going to rise negative 5, which is a fall of 5, and run 1, starting from 2 on your y-axis. All right? What are the effects that are going to be applied to our line? The inequality, the final inequality, that's what you're looking at, not the original one. Okay, I think I made a change here. There's no line underneath there, so let's take that out, take that out. Okay, so you look at the final inequality. That's why you always want to put it in slope-intercept form, because it tells you the correct orientation of the inequality. So since it's greater than, we're going to have, so it's got switched around. Our inequality is greater than now. So it's going to be a broken line. Why is it broken? Because we do not have a line underneath the inequality, and the direction of our shade will be upwards. All right, let's go ahead and graph the line. You start from 2, 1, 2. You're going to rise negative 5, 1, 2, 3, 4, 5, and you're going to run 1. You end up right here. Okay, so we're going to have a broken line through those points. All right, so there you have the broken line through the 2 points we just graphed. Our inequality says greater, so we're looking at all the points to the right. Okay, above the line, if you see the tilt right here, this is the top and that's the bottom. Now, do you see where the solution region is? Right here. This is the only region that both inequalities are pointing to. All right, so this region right here, that's our solution region. So any point that's in this region will satisfy the inequality. But one thing I want you to note is that any point that's on this line, including that point of intersection there, is not a part of the solution because this line is excluded from the solution set. Okay, so that's that. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful to you, do give us a thumbs up. Your positive feedback is very important to us. If you have any questions or comments, include it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other great tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.